I just wanted to hop on because there was some SmartWork homework that seemed to give people some troubles. And so I wanted to go over this. Now, we are told here that we have a container that has 650.0 milliliters of a solution containing ammonium ions. It wants to know how many grams of ammonium ions are in the solution if the molarity is 0.742 molar. Now, let's think about what we're given. We're given 650.0 milliliters, which is a volume. Let's consider changing that into liters because we're also given capital M, which is molarity, which we know is a unit of moles per liter. Okay, and I'm also going to write up here my little helpful circle here. Remember, molarity is moles divided by liters. So if we know liters, we convert that to liters. So 650.0 milliliters is 0.6500 liters. So if we know volume and we know concentration, we can find the moles of ammonium ions, and then from that we can get to grams. So this is a very similar problem to what we've been doing. It just is worded just a tad bit different because it started with milliliters, so we have to get it to liters. And maybe you got a little thrown off by the ammonium ions. And this is just the same thing. We're going to need to find moles and then convert moles to grams by looking at the periodic table and finding the molar mass of 1 N and 4 H's. Okay, so let's get started. To convert, remember, from milliliters to liters, let's just do that real quick for everybody that's a little bit rusty. 650.0 milliliters. Remember, 1 milliliter, we put a prefix next to, a 1 next to the prefix. 1 milliliter is 0.001 liters. So that would give me the 0.6500 liters. Okay, so that's our volume. That's this part, the liters. And we know the molarity. So let's multiply those two together now to get moles. So I'm going to do 0.742. We know that this capital M stands for moles per liter. I'm going to times that by the liters that we just found, 0.6500 liters. So the liters and the liters will cancel out, leaving me with just moles. Let's plug that into our calculator. We should get 4823 moles of NH4 plus ions. Now, we're almost there. We want grams. So we're going to go one more step and we need to find the molar mass. Of 1 N and 4 H's. And that should tell me that it is 18.038 grams in 1 mole, or in 1 mole, there's 18.038 grams. So which one do we need to use? Well, if I'm starting with 0.4823 moles of ammonia, I need my moles on the bottom to cancel out. So I need to use this guy. In 1 mole of ammonia, there's 18.038 grams of ammonia. All right. So the last step here is to plug and chug, multiply across, and divide by 1. My calculator gave me 8.699727 grams. So the last step here is to look at significant figures. My 0.742 in the concentration is 3 sig figs. My volume was in 4, so I want to finish with 3 significant figures. 1, 2, 3. That 9 will round that 9 up. So 8.70 grams of NH4 plus ions. Now, one thing to make sure that you notice on your SmartWorks is that you have a periodic table available to you so that you can find those molar masses. But again, you can also use the resource that you have been given in class. Let's look at question 10, this next one. We're told that we have about 6 times 10 to the 9th grams of gold. So that's a lot of gold. That's a lot of grams of gold. It's thought to be dissolved in the oceans of the world. If the total volume of the ocean is 1.5 times 10 to the 21 liters, what is the average molar concentration of gold in seawater? Well, if we want concentration, we know concentration units is moles per liter. Well, are we given moles? No. So number 1, we have to go from grams to moles of our gold. And we are given liters, so that's going to be our denominator. Okay, so let's look at the periodic table and find gold. So I'm going to start with 6 times 10 to the 9th grams of AU. Now I'm going to look at the periodic table. I want grams of AU in my denominator. For 1 mole of AU, the periodic table tells me that its mass is 196.967. So grams and grams are diagonal from each other, so they'll cancel out. And we're going to get 3.04619 times 10 to the 7th moles of gold. Okay, so we've got step 1 done. Step 2, so that's step 1 here. Step 2, let's calculate our concentration. We know that molarity is moles divided by liters. So we're going to type in our 3.04619 times 10 to the 7th moles of gold divided by my 1.5 times 10 to the 21 liters. Now make sure on your calculator that you are using parentheses to make sure that this does not get gunked up. My calculator tells me 2.030797 times 10 to the negative 14th power for concentration. I'm going to look back and let's look at significant figures here. I started with 2 significant figures for the volume and just 1 significant figure for the mass. So we're going to end with 1 significant figure. So we're just going to finish that with 2 times 10 to the negative 14th molar concentration. This question also seemed to throw some people for a loop. Remember, always think back to this little helpful tool. Concentration is moles divided by liters. So for part 1 of this question, we're given liters and we're given molarity. So liters and molarity. So if I multiply those two together, that will give me moles. Then, so if I'm going to put a little multiplying here, that will give me moles. But my question wants grams. So I need to look at the periodic table and figure out the molar mass of NaCl. And you can use this little tool right here, the periodic table, or use your paper periodic table to get grams of NaCl. And make sure that you're watching significant figures. For 1.00, that's 3 significant figures. And for 0.245, that's also 3 significant figures, so we want to end with 3. For part 2 and part 3, be careful because I'm given volume in milliliters. So we want to get that into liters, because if I know volume in liters and concentration or molarity, that's in moles per liter. If I multiply those two together, that will give me moles, and then you know how to get to grams. Same thing here. This is in milliliters, so get it to liters and concentration, and you're given the compound here. So you can find the molar mass of 1 carbon, 3 H's, an O, and another H. So 4 total H's. And same with this copper sulfate, copper 2 sulfate, 1 copper, 1 sulfur, and 4 oxygens. Just to make sure that you're feeling okay with this part 1, if I multiply 1, so my volume times my molarity, 1.00 liters times 245 moles per liter. We can see that those liters cancels out, and that would give me 0.245 moles of, what is it? NaCl. And then I could take that one step further, like I did right up above, and say that 1 mole of NaCl. If I add up 1 Na and 1 Cl, I should get 58.44 grams. So 0.245 times 58.44 should give me 14.3178. And then again, remember, we want 3 significant figures. So 1, 2, 3, and that 1 isn't going to do anything to that 3. So 14.3 grams of NaCl in that solution.